This question is about the free fall motion of the two balls, and I will explain you by the two methods. The one is graphical and second is mathematical, means in which I will apply kinematics equations. So in this question you see there are the two balls, ball A and ball B. Ball A is dropped 1 second before ball B. This is very important that the ball A will always have 1 second more. So if we are counting the time t is equal to 2 seconds for the ball B, it means the time elapsed for the ball A is 3 seconds. Okay. Now, which one of these answers is correct? And we are neglecting any presence of air resistance, which means it's a free fall motion. Okay, so let's figure it out. So let's walk towards a graphical solution that is relatively easy. Okay, so remember that I am taking the magnitude of the position on y-axis, whereas the time is on x-axis. And the graph that I will draw for this, the background of this graph is this kinematic equation, which you know that the initial velocity is 0. That's why it means that the position is directly proportional to t square. Okay, which means that we will get this graph. Let's say if I start this graph from 0 seconds and I assume that this is a graph for the ball A, for example. Okay, so this should be, and I have drawn the graph according to this relation. So for the ball B, we will have the same graph, but that will be starting right after 1 second. So if this is the 1 second, so I'm drawing the same graph, dear students, you see is starting from the 1 second. So at the 1 second, what is the position for the A? That is YA. Okay, and the position of the ball B is, because ball B is just starting. So notice that, is it not that this is a distance between these two? This is the separation, right? Which is exactly in this diagram. This is a separation in beginning, right? And if I go further, let's say this is some time which is of course more than 1 second, and if I notice that this is a position of the ball B and this is a position of the ball A. Okay, so you clearly see that now the separation of the both balls has increased, and we will see as the time is going on the separation is increasing. Okay, so the distance between the two balls increases. That's why the option D is right answer. And now we are going to the mathematical solution. So if we write equation for the ball B, so we can say YB, the position of the ball at any instant, is equals to the initial position of the ball B plus the initial velocity times t plus 1 over 2 acceleration times t square. Okay, now so this is 0. Okay, so we can simply write equation. Acceleration is negative g, so it will become negative 1 over 2 gt square. So students, let's say this is our equation 1. Now we will repeat the same process for the ball A. So you remember we released the ball 1 second before, right? So it means that when I will write equation for this, okay, so its initial velocity is also 0, but its acceleration is I mean this time is t plus 1, because it will always 1 second ahead. All right, so now its this velocity is also 0. And don't you think that the initial position of the ball A is half of the initial position of the ball B? It's better if I replace it here, that y initial position divided by 2. So it is negative 1 over 2 g into t plus 1 whole square. Okay students, so this is our second equation. What we have to find out, we have to find out the separation between the two, and that is y b minus ya, or ya minus yb So now I'm going to subtract these two equations. Okay, so I'm just plugging the value. It is not difficult. You see here, this is the equation 1 minus into equation 2. So students, this will be negative y ob over 2. Okay, and plus 1 over 2g into t plus 1 whole square. Now what you have to do, you have to solve it, and you see that this will subtract from this one, all right, and it will become initial position of p divided by 2, all right, and negative 1 over 2 gt square plus 1 over 2g. I have to open the square of this one, right, which will give us t square plus 1 plus 2t, all right, and then you can open it, you can open the brackets. So plus g over 2 plus 1 over 2g into 2t will give us gt. All right. Now we see that these two terms are cancelled out, and as a result, we see that the separation between the two. Okay, students, the separation between the two is equal to this constant. Okay, because this is a constant value plus g over 2 is also a constant. But look at this gt factor. Don't you think as the time is increasing, this gt factor will always increase? So when it will increase, automatically the separation between the two will also increase. So this was lengthy, but I hope you understand the graphical method as well as this one.